All right. So let's hop into part two here. A couple finer points I think I should cover about um, this approach. The angle, the viewing angle in Osky Studio is really independent of the viewing angle here in Blender. And what I mean is, this angle looks great. I'm showing you just the front top edge, but I can easily sort of rotate around to the back inside of Osky Studio because I'm just turning these twisters here. You sort of do whatever you like. If your goal is to only show the viewer the front of your object, but then have your object move around, what you really need to do is sort of lock in inside of Osky Studio the angle, and then move the object, rotate the object inside of Blender in front of this viewer object. It's sort of like this virtual camera. And importantly, if I were to select this and try to make an animation to rotate it, that would not solve the problem because this object, the code here, this animation nodes code, doesn't care where this object is located. I can move it over here, right? And what it really cares about is the distance between the viewer and this guy, right? That original cube, which is sort of that's the input to this whole series. Where this is located is irrelevant, really, for the purpose of what it looks like in this setup. I'm gonna make it go back to 0 though. So if you want this to sort of rotate or move or evolve in front of the camera, and the camera here is sort of this viewer and then the view angle that you've chosen inside of Osky Studio. What you need to do is go to the cube, that original sort of input object. Make a quick sort of spinning animation. And if I go to the end here, it's 360. Yeah, okay, there it is. All right, so here's an animation that causes this object to spin. But if I hide that original cube and I turn the target back on, you can see it kind of spins in front of this viewer, and therefore is sort of picking up the ones that are nearby and hiding the ones that are far away, right? So any animation that you want to do where you're sort of taking advantage of this view angle, you really do need to do it here in Blender. And then again, this is pretty groovy looking if you want to do both, right? This guy will evolve as this guy evolves. That's a little too fast to be interesting, but all right. So that looks pretty cool too. And complexity is really kind of limited by your imagination and maybe your computer's horsepower. We'll turn that back off. But without further ado, I want to switch to a couple other approaches that are a little stronger for hiding sort of back faces, hidden faces. And again, this guy is distance based, so it's really a Z clip. If this object's too far away, it doesn't really work. If you had some objects way in the background that you wanted to also show in the scene, this wouldn't work, right? Because it doesn't care that it could see it from the distance. It cares what the sort of spherical space around this particular object. Can it reach the polygon you're trying to see? Okay, but let's switch to another model. This one's angle based, and whoops, let me go back here and detach this guy just to make sure we're not tripping over it later. Okay. right, so an angle-based, first of all, yeah, there's a lot more going on here, and that's just something to get used to with animation nodes. You know, it's a visual programming language, but in some cases it's really pedantic. Like if you want to do a little simple math, you have to have 3 or 4 nodes to do 3 or 4 math operations. To put them all in one is more complex. You have to sort of build it into a script node, and I'm not going to show you how to do that, partly because I don't know how. But this guy, let me just show you how it works. Like this one, I have a more complex object that I'm going to use it on, which is this cube multi. And this one is really just 3 cubes put into the single object. They have this same subdivision surface modifier applied to them. And there's the objects inside of Osci Studio. And again, with this one, it's a little hard to tell which is the front and back face of this guy. And so this approach I'm going to show you solves the front and back face issue. Like if something is far away, it'll still show it to you if it's facing you. But this particular version does not solve the hidden lines version. The number 3 I'm going to show you does. But let me walk you through this one first, because I think it's pretty useful. And if you don't really need a lot of hidden line control, this one's pretty cool. All right, so as before, we're going to take this object, feed it into animation nodes, do some transformations, and then spit out a new transformed mesh. And then we're going to hide the original, and the transformed mesh is going to be the thing that the viewer sees. So let's put it in there. Again, using the concept of a viewer view angle. So I'll pull this guy back a little bit. There. And then this object can be this target. Did it right? Yeah, there we go. Okay. So here is the sort of version 2 of this thing. As I change the object, it changes which faces in this sort of transformed object are shown. The rest of them are hidden away. See, it's like a light casting down on these objects. I think I can afford one more. Yeah, let me go to 3. Nope, I crushed it. Oh, I see. Okay, give me a second here. This 3000. 3. Still doesn't like it. All right, let's stick with 2. There are too many vertices, and Osci Studio said no. All right, so we'll kind of rotate this around. You know, in this sort of instance, again, if I want to make an animation, if I make an animation of the original object, okay, and then I will send it to here and call this one so 20, so 180. Best looking animation, but it'll do. Yeah. Okay. Zoom out a little more. So if I were again to turn this guy on, and then as I go through the animation, the objects move, more and more of the various pieces come into view. Once again, if you think about the view I've got is sort of from the side, from this side, is how we're seeing it through Osci Studio. So if I want the sort of face-on view from this guy, I need to rotate it back inside of Osci Studio. Something like that. And then as it turns, you see the objects are sort of trying to keep their faces that are facing me in view. It's only showing me the front faces, right? So if this is sort of the top view, I'm not seeing those back faces anymore inside of Osci Studio because this script is hiding them. What this script is doing, going to walk you through some of the basics. Again, here's the input object. This thing I'm calling cube multi. Taking and pulling out the object mesh data, and then separating them and putting them into a sort of transformation, and then recombining them into a new mesh, outputting that new mesh into a new object, and then displaying that object over here. This one's more complicated. This is actually a subprogram or a loop. And what it's doing is it's looping through every one of these polygons and trying to decide what is the view angle. Every one of these polygons has a normal, which is basically the the vector that the object is facing. So imagine at the very center of this face, this guy here, there's a vector, there's a line that starts dead center, and perpendicular to the surface of this, it shoots straight toward us here. And what this subprogram is doing is it's trying to decide what's my angle to that, right? And if my angle exceeds sort of 90 degrees, then I don't want to show it. But if it's under 90 degrees, I do want to show it. So all of these faces on this sort of front part of this sphere are less than 90 degrees. And then as soon as it exceeds 90 degrees, like this guy here, it hides it. And that's the logic that's going on here. Walk you through the loop quickly. The way that animation nodes works is if you have a list, in this case I've got several lists, the object mesh data has vertex locations, edge locations, polygon indices, etc. I'm looping through the polygon centers and the polygon normals. Polygon centers is the physical location, the 3 XYZ location of the center, and then the normal is that angle that we talked about. And what I'm doing with this magical piece of math through the pink area here is for every one of the looping through all of the polygons that are in the scene, or in the object, excuse me, and for each one calculating what is the view angle from this center dot to the center dot of the polygon, and then comparing that angle to the angle of this sort of polygon normal that's coming out of the center. All right. So empty location, this is that sort of viewer empty I mentioned earlier. Polygon normals, polygon centers. So it's sort of feeding it in as variables into this loop. And then it's doing some vector math. It's saying, what is subtracting this location from this location is an angle. So it's basically that's an angle from here to the dot, and then it's comparing it with the actual normal coming out of the center, and then it's doing this thing called a dot product, which, as I read on the internet, I didn't know this, but it allows you to figure out the angle between two vectors. And then this is actually a factor that it's sort of comparing, saying, okay, what's the angle? And you can see as I adjust this angle, it changes how much of the how many faces are showing, right? So a low angle, it starts to show more. Actually, I'll show you here. It's sort of wrapping around because it's allowing even more to come into view. And 0.24, is that what I think I settled on? Yeah, that's sort of my, for this demonstration, what I chose, but you know, again, you can play with these variables, but that's the logic. And then it's saying is that angle bigger than this number, or that dot product, excuse me, bigger than this number? And if it is, send a 1.06. Otherwise, send a 0. And the 1.06 is a, why is 1.06? Not just 1. It should be 1. Okay, that was a mistake. My apologies. Send the 1 out to here, and then take that value and sort of spit it out as an output into this matrix that's going to be applied to that original set of data. And then that's back up here, that's the matrix is going out to this. Here's the original polygon data. It's applying this matrix, which is basically for each polygon, transform it using scale. Sorry, that was this guy here, scale, and scale it. And in this case, it's ones and zeros. I'm not using that sort of fall off notion that I use on the other ones. This is just like a sharp edge. And then output it. And there you go. So that's version 2. This is face driven. What it doesn't do is hide hidden faces. So if we think about, if this object was rotated, say that way, okay, and if I get my Oscilloscope Studio alignment roughly aligned with that, okay, even if I sort of show you this version, which is showing you the view from here, it's still showing this overlap right here and right here. These guys, by rights, this guy in front here should be obscuring most of this one, and it's not. And again, the reason it's not is because this method doesn't care where things are located. It cares about the view angle of the polygon. And so, again, this one works in some situations, is not as complex as the next ones I'm going to show you, but it doesn't solve for that problem. So let me jump in and show you version 3, which does solve for that problem. First things first, though, I want to disconnect this guy and this guy. All right. And as expected, this one's even more complex. But bear with me. You'll like it. So first, let me show you how it works, what it does. Viewer and this is target. This guy. Okay. So remember, when we left our heroes, we had an object that shouldn't be visible in the background, but it was. Now that object is hidden. And as the viewpoint kind of goes up a little bit, now you're starting to see those items behind there. And that's sort of the angle you're getting there. And now as I move my viewer higher, I see it some more. Now these are starting to interfere in the Oscilloscope Studio, but that's because my view angle on the Oscilloscope Studio is not following, but as I sort of follow it up, it will. And then, again, it's still looking at the front face, right? What's the view angle? So it's solving for that sort of hidden back faces part, but it's also solving for the hidden objects part, right? And this is one that I've used a lot. Once I sort of figured out how to do this, this BVH method, I use all the time now. It's very powerful. I'm going to give you guys a copy of this so you can use it, but let me walk you through what it's doing so you can debug it if you get stuck, and build your own and roll from there. As before, taking the object mesh data from this original cube multi-object, tossing it into animation nodes. In this case, we're constructing what's called a BVH tree, and it's essentially a way to store the mesh data that allows us to do some tricky things. In this case, what we're doing is ray casting. And the technicalities, I couldn't tell you all of them, but the short version is we're taking from this, again, from this viewer location, the center point, we're taking and casting a line between that and every one of the polygons that are in this object. And I say the object because this cube multi, even though it's made up of sort of 3 spheres, in Blender's opinion, it's one object, because I can manipulate that one object. I can go in and edit all of the parts of that object. The fact that there's 3 disconnected spheres is irrelevant. It's an object, right? So now what the ray casting is doing is taking and drawing a line to the center of each of these polygons that's in this object, okay? And then it's also testing to see, it's in drawing that line, it's testing to see what is the first point on the object that it hits. So in the case of this front face, it draws a line from here, draws it. It doesn't want to let me do that. All right, never mind. Oh, I need to show it, that's why. All right, let's make a new one. It's drawing it from here to that point right there on the center, right? From here to here. It's also drawing a line to some object that's in the back, right? When it draws a line for the object in the back, it's also testing, is the first point on the object that I hit while drawing this line to that polygon center, is that first point that polygon center I was aiming for? And in the case of these front faces, yeah, that's the first thing I hit, because there's nothing in between me and nothing blocking my view, right? But in the case of trying to draw to one of these back faces, the answer is no. If you're trying to draw from here to one of the polygons that's on the back of this sphere, you're gonna hit the front of the sphere first, right? On the way to the back of the sphere. And so that's what my logic is testing for. It says draw a line from this viewer to each of these polygons. And then while you're doing that, do a ray cast test to see if the first hit is that same dot. And if it's not, then that face is going to be hidden because it got obscured by the thing that I hit first, whatever that thing was. But if it is the first thing, then go ahead and show it. And that is the logic that we're applying in this wonderful set of code here. So the quick version is, and oh, by the way, this BVH tree, this allows you to do that ray casting, right? That's one of the benefits of it, it allows you to efficiently test for hits and collisions and things like that. So grab the mesh data, push it in, create a BVH tree, and oh, by the way, get the location of all these polygon centers and get the location of this viewer. We did before, same thing, push it into this loop. And then once you're in the loop, do your testing, take your loop input, find the vector between the two locations, this location and the location of that polygon center. That creates a vector. That's my ray direction. Ray start is my viewer location. The BVH tree is the sort of object that I'm casting rays through. And then this is telling me what is the location that I hit. Now, here's the, sorry. What is that? Oh, I beg your pardon. Ignore all this. That's useful. It's just extraneous. Here's what we need. Compare the place that I hit with that original location, and was the polygon that I hit? Oh, sorry. The polygon that I hit is here. It says which polygon did I hit, and that's one of the things it tells you. And then check that against the one I happen to be shooting at right here. And if are those the same, and if they are, then include that polygon in the view list, and if not, exclude them. And that's kind of what this scale matrix is doing again. It's in fact, this is a convenient approach because it's ones and zeros, and ones, Boolean 1 is yes, and Boolean 0 is no. And so what I'm doing is I'm just taking that value, that Boolean value, and using it to scale the object to a 1 or to a 0. These viewer things that are here, this is just for debugging. I can delete it out. If you want to see the value of a node as you're going, that's kind of a tricky thing. Useful, I should say. And then, sorry, there's some extraneous stuff that I left in here that I don't need. And then once I've determined, that's extraneous too. Let's simplify this as we go. All of this is not helpful. Okay, so this is a scale matrix, ones and zeros basically, that we're going to apply to that original set of polygons. So here's that set of polygons again that we sent in and did a bunch of testing inside of the subprogram. The results of that testing are here, this matrix, and here's the original polygons again, transformed by that matrix of ones and zeros. And here's the transformed version of that polygon set, and then here's the output. So this output is showing you just those that, essentially only showing you the polygons that were the first ones hit when we raycasted at those polygons. And so you sort of get in the same spot that this guy's in. As I look across this world, which polygon did I see first? And so what that hides is these polygons that were here that were obscured behind this front one. And it also hides sort of all of these back faces. All right. So this is the BVH tree method, which is my favorite because I think it really, sort of powerfully gets to the point. Hides the hidden objects, hides the back faces, does so pretty efficiently. And this is actually not as bad a set of code as it looked when I first started because I pruned it down a little bit. But it's, and really the main benefit to the user, this is a lot easier to understand visually than that. And this one still looks pretty easy, but if you have a lot going on or something interesting was happening sort of inside of one of these, right, you would not want to have the back faces obscuring whatever that interesting thing is. So that's one of the benefits. And again, the second benefit is this sound is probably 1/2 or even 1/3 of the frequency of what the sound is with all the back faces showing. And that really gives you a lot more versatility sonically in sort of using this output in music. All right, I think I've covered what I wanted to cover here. Happy to answer any questions down in the comments. Well, thanks for watching. Oh, again, I will put links to this project in the footer. And I'll also put a couple links to some recommended tutorial series. Folks that are doing tutorials on animation nodes in particular that I've found really useful. So, thanks for watching. Have a good one.